And we'll get started. So the first couple of questions, you have to know the following. You have to know that cosine of negative x equals the cosine of x. So basically, if you have a negative number inside, it becomes a negative number there. And cosine, and I'm assuming you're doing all of them. So like secant would also follow this because it's like cosine.
Okay, yeah.
All right, so number 2, I'll actually just handwrite it here because it'll be a little quicker. Sine is, and that's because this is an even function. Maybe didn't say that at first, but so if you have sine of negative x, that equals negative sine of x. Basically, the negative inside comes out, and that's because it's an odd function here. And this becomes really useful when you're trying to determine values in the unit circle. So this becomes negative sine of 2.75. Now, if you were going to use your calculator, you would want to have your mode in radians. So sometimes students ask, well, how do I know whether it's radians or degrees? Well, if you see a degree symbol, which I don't, and I didn't write one here, then you know if it's in degrees, it'll have a degree symbol.
Yeah.
Okay, so the 3 there is the tangent of -5, which is the tangent. A tangent is like sine. It's an odd function, so it becomes minus tangent of x. It's also odd there, so this becomes minus tangent of 5, and that's it. You don't have to do any more on those. So move to question 4, and question 4. So you have to know all of the reciprocal identities, all the trig functions in terms of sine and cosine. So cotangent is 1 over tangent, which is a good place to start. Secant is 1 over cosine theta. Now tangent is really sine over cosine. And hopefully you can see that. Sometimes the screen kind of frames it weird sometimes. So now you just flip the bottom, like in this top fraction, you flip the bottom fraction, so it becomes cosine theta over sine theta, and this is really 1 over cosine theta. And then if you remember, when you divide by a fraction, you multiply by the reciprocal. So it's cosine theta over sine theta times cosine theta over 1. So it becomes cosine squared theta over sine theta.
Okay, yeah.
All right. So the next one here, there are 3 Pythagorean identities that you definitely want to know. I'm going to just do a quick Google search here for this trig cheat sheet is what it's called. I prefer reference sheet, but let me send this to you in the chat. It's got all the formulas you'll ever need for trigonometry on this one sheet, but the one that we need for this problem is actually on page 2. There are 3 Pythagorean identities, and the one that we care about here. So like what you're looking for. I know it says to write everything in terms of sine and cosine, but you definitely want to use these identities first. And what you're looking for is like whenever you see a squared and a 1 plus a square, and sometimes a 1 minus. So your tangent, your 1 plus cotangent squared is cosecant squared theta. Tangent squared theta. Okay, so that's sine squared theta over cosine squared theta, 1 over sine squared theta, like that. And then these cancel, and you're left with 1 over cosine squared theta, which does become secant squared theta if that were the goal here. It's a little unclear to me what it says right in terms of sine and cosine. So I guess I think this is the right answer for this, and maybe I guess what I'm trying to say is you stop here
Okay.
You don't have to keep going. I'm not really sure though.
I think, yeah, I think that's where we would stop.
So the reason you're doing this is because for problems like 7 and 8, you get really you have to use these steps to um, prove the identity or verify the identity. So this is actually a really good question, because you do have to write everything in terms of sine and cosine. So cosecant is 1 over sine theta, cotangent is cosine theta over sine theta, and you can see that you can combine the numerators and keep the denominator the
Mhm.
same. I mean, it's like, what's 1/3 plus x over 3? Well, it's 1 plus x over 3. There's always kind of an analogous problem.
Mhm.
So um, all right, so that's kind of that. Verify each identity is next. Any questions? Anything you want me to clarify before we move on to that?
No, those all make sense right now.
Okay, because the next part here becomes a simplification of, or not a simplification, it's an extension of what we were just doing. So what you have to decide first is you have to decide which side you're going to work on. And what most students don't like to hear is it's actually the more complicated side, the one that looks worse. And so for me, the one that looks worse is the one on the left. Okay. Some instructors allow you to work on both sides. I would check with your instructor to see if that's allowed, because some of them get really particular here. So we're gonna work on the left, and on the left, it's like, well, what do? Well, you use some of the strategies that I just talked about, like in the previous problems. You write everything in terms of sine and cosine. So tangent is sine theta over cosine theta, sine theta up here. Okay, and sometimes they actually want you to draw this like line to be like, I am not working on the right hand side.
Mhm.
So notice the bottoms are the same. So you can write this as 1 minus on in the numerator. Sine theta times sine theta is sine squared theta.
Mhm.
And again, if you go to that reference sheet I showed you, and I'm going to snip it in here, if you have Pythagorean identities like this, you when you see a squared, you should say, oh, maybe it's one of those. So it's actually this first one here. If you move the sine squared over, so the first one is sine squared theta plus cosine squared theta equals 1. If you subtract sine squared theta from both sides, you get cosine squared theta equals 1 minus sine squared theta. And just be careful here. I don't think you'll get any kind of wrenches or wrinkles in your problems that are kind of oddities, but
Mhm.
like it's not 1 plus, and sometimes students don't see that. So it becomes, the numerator becomes cosine squared theta over cosine theta,
Mhm.
and then those cancel, and you're just left with cosine theta. Now,
Okay.
some instructors actually want to see this on the right. I don't know what yours will want. Like if you just went directly from here to here without showing the stuff on the right, I'm not sure if they would be okay with that. Now we've gone so deep into this problem, we've actually forgotten what it's supposed to equal.
Mhm.
And if you look, cosine is 1 over secant theta.
Mhm.
And that's why I was asking you, like, do you need to work on one side or the other or both? Because it would actually be easier to go up here and say, oh, well, this is really cosine theta. And then
Yeah.
you're done at this step here, rather than continuing.
Oh,
All right. If there's no questions on that, we'll look at 8. And again, you have to make a decision of say, well, which side do I want to work on? Which side actually looks more complicated? If you got a kind instructor, they'll just always make the left side, since by convention we tend to work on the left side. So that's 1 over sine x. All I'm doing is giving sine x to both of these plus cosine x over sine x. 1 over sine x is cosecant x. Cosine over sine is cotangent. So sometimes it's as easy as just working it out with sine and cosine, and you end up getting the answer there. every year they give this as the same review for this class. So if you know a friend from last year, the exams probably aren't that much different either. So this one right here, it's a known value on the unit circle. If you go to, I'm sorry, it is not a known value in the unit circle. You've been studying the unit circle, and as part of studying it, you're supposed to like really know the first quadrant really well. And then this problem is really the tangent of, and depending on your book, the reference I use, it's going to be an alpha plus a beta. And what I mean by that is like there's two angles that add up to 5 pi over 12. And these are kind of non-obvious. So it's like, excuse me, it's like pi over 6 plus pi over 3. And you can see here that when you make a common denominator of 12, you get 4 pi here. Ooh, maybe this isn't right. Maybe it's pi over 4. Sorry, I'm struggling here to figure out how to make 5 pi over 12. So it's some combination of usually of like pi over something. So sorry, let me write them all out here. So pi over 3, pi over 4, pi over 6. So if I write these all over 12, you get 4 pi, 3 pi, and 2 pi. Yeah, I'm sorry. It's pi over 4 and pi over 6. That's the issue here. Because you can see those two add up to 5 pi over 12. So you do that, and then what you need is a sum and difference formula. And that again is on that reference sheet that I sent you. So really it's very formula heavy. Are you allowed a reference sheet on this exam?
I think I am.
Okay, well, this would be a good one. So notice like all you got to do is substitute your values in for them. So the way these reference sheets work is that the plus or minus, like if it's plus, in our case it's plus, it maps to the top one. So the plus goes to the plus, but then the top one is a minus down here. You just follow the order, whether it's top or bottom. So for you, tangent of pi over 6 plus pi over 4, and the order doesn't matter. You could do pi over 4 and then pi over 6 plus tangent pi over 4 over 1 minus tangent pi over 6 tangent pi over 4. And from here, it's just evaluating it from the unit circle. So the nice thing is tangent pi over 4 is a known one. That's 1. But tangent pi over 6, that's sine pi over 6 divided by cosine pi over 6. And so let me actually write that out here. Sine pi over 6 over cosine pi over 6. Let me actually write it off to the side. Are you pretty strong with your unit circle, or do you feel like it's still something you got to memorize?
I think it's still something I have to memorize.
Okay, yeah, you're not alone. It get calculus students that just don't get it. And so this is square root of 3 over 3. So it ends up being square root of 3 over 3 plus 1 over 1 minus square root of 3 over 3 times 1. And so like to me, this is done, but there's simplifying that needs to happen from here. And I don't know that we should spend a lot of time on that. Maybe if we have time at the end.
Okay.
But just know that like the trig is done. You don't have to do any more, like you did the trigonometry. You're just now figuring out what it is. So let me snip 10 in.
Okay.
And these are kind of grouped together as all these formulas that I've just said. You got to know which one and why. So like when I see this, I see sine alpha cosine beta minus cosine alpha sine beta, or if you prefer like A and B or X and Y, depending on what your instructor is doing. But notice that the 76s are the same and the 31s are the same. So what you're looking for here is, let me snip this in. It's again, it's a sum and difference formula. It's just going backwards. So what do we got here? We got sine, cosine, cosine, sine. So let me just snip them both in so you can see what I'm referring to. So like what we're looking at here in your problem is the right-hand side. You're given sine alpha, cosine beta, cosine alpha, sine beta. You're dealing with this top one here. Because notice the other one's cosine, cosine, sine, sine. So that's not right for this. And then because it's minus here, there's a minus that goes with the bottom one there. So this becomes sine of 76 plus 31. So like the end result's really easy and straightforward, but to get there is a little bit harder. So this is sine of 107 degrees. And I guess it says, that's all that's needed. Give me just a moment, please.
Okay.
Okay, so those were both sum and difference formulas. Like one's a forward and one's like a backwards. So you gotta be strong on both there. Okay, 11 tells you what to use, so there's no guess like, oh, what kind of formula is it? It says literally like use the half angle formula.
Okay.
So the half angle formula is let me grab those here. There is one for tangent, but I'm just going to grab the ones for sine and cosine because that's what we're trying to figure out here. So it's like, well, how do you use this thing? Well, because we want cosine of 105 right here, okay, we're obviously going to go with the cosine formula. Now, what it's saying though is that this theta over 2 is 105. Theta over 2 equals 105. Theta equals 210 degrees. Okay. So the reason this matters is that angle you find is what goes into this formula here. So cosine, and I'm going to write it this way, 210 divided by 2, which is 105, equals plus or minus square root 1 plus cosine 210 over 2. Is that okay?
Yeah, it makes sense.
Okay, so cosine 210, you got to look up on your unit circle. There are ways to do it faster, but it ends up being minus square root of 3 over 2 all over 2. And now there's this like business of like, well, what do you mean by plus or minus? So the plus or minus is based on the location of theta divided by 2. So like 105 degrees, where is it? Well, it's over here in the second quadrant. And you probably saw this ASTC at some point.
Yeah.
What that means is that they're all positive in the first, sine is positive in the second, tangent's positive in the third, cosine's positive in the fourth, and like kind of like a light switch or a logic, one is on, the other are off. So in the second quadrant, your cosine is negative. So you do have to choose the sign. And sorry about that. I'm getting all messed up here. There we go. So it is negative. And you would say, no, it's not plus. You do need to simplify. We'll just guessing, we may or may not have time to get through everything. So I'm going to skip that for the moment. Is that okay? Or is there anything that's unclear about that?
No, that all makes sense.
Okay. Again, kind of very formula heavy, very much like, if you don't know the formula, you have no chance doing this. Okay, so this one here is they're like, sometimes it's good to go like what they're asking for. And if you look on that cheat sheet reference sheet I sent you again, there are a couple of double angle formulas. Sine of 2 theta is the most common one. It's the one you tend to see on like standardized tests. And it's, here it is. It's like, okay, great. I got sine of 2 theta. It's 2 sine theta cosine theta. You've only got cosine theta. So now what? Well, they're telling you that you're between 90 and 180. And what I call this, what I'm about to draw, is I call it the reference bow tie. So there's actually 4 triangles you could draw depending on which quadrant you're in. And this is telling you you're in quadrant 2. So your triangle looks like that. So you got a, it's not very good. You got a triangle that looks like that. And they're telling you here, they're saying, okay, the cosine of theta adjacent over hypotenuse looks like this. So because the hypotenuse has to always be positive, we put the 9 there and the minus 2 square root 14 here. And then you still have to solve for b, or the missing leg. You want to solve for b. So that's Pythagorean theorem, PAG, if you will. That's minus 2 square root of 14 squared plus b squared equals 9 squared. And that's 4 times 14, 56 plus b squared equals 81. B squared equals 25. So b equals 5. It could be plus or minus 5, actually. So you go back to your drawing and you think, okay, well, if I'm in this quadrant, am I going up or down? That tells me whether it's positive or negative. So that means this is 5. Why do you need all that? Because you need sine. You have cosine, it's given, but you need sine. You need the other one. So your cosine theta was given as minus 2 square root 14 over 9. I know it's not in the drawing here. Sine theta is 5 over 9. You go back up, it's the opposite over the hypotenuse. So then the 2 sine theta cosine theta is 2 times 5 over 9 minus 2 square root 14 over 9. And just little, this one will briefly simplify, minus 20 square root 14 over 81. The answers don't make, like, they don't mean anything. You don't get a number and say, oh, that makes sense. They're just sides of triangles or ratios, things like that. So there's not a great way to figure this out. Did I skip a bunch of questions?
No, this was just a short review.
Okay, because I see a 7, 8, 9, 10 now. And I'm like, wait.
She copies and pastes them from like other things. So she goes out in order.
Okay. Is that the end of the quiz review though?
Yes.
Okay. So do you want us to look at starting at 7 on that, or do you want to pick and choose? What's kind of your
from the other things that I sent you? Yeah, we could start on 7.
Okay. Are the instructions here to solve?
Yeah, it's just solve each equation.
And do you know if it says in the from 0 to 2 pi?
Oh, it says the interval is 0 is less than or equal to theta, which is less than or equal to 2 pi.
Okay, very good. All right, so there's several different problems here, but they all get condensed to the same type. So I'm going to make a substitution here. I'm going to let u equal 2 theta. So this becomes sine u equals minus 1/2. So on your unit circle, where is the y value equal to minus 1/2? So that's going to be here and here. And like, if you have a unit circle handy, you just read off the answers, but you really want to be able to do it, on your own without it. But I don't really have any, frankly, I don't have any encouragement for it. It's you got to either want to learn it or not. There's not a pleasantness to it. So these are the 2 possibilities, but this is for you, and we don't want you. We want theta. Okay, so the sort of the shortcut here is to say, okay, well, 2 theta equals 7 pi over 6 comma 11 pi over 6, and then you divide each of these by 2. Okay, so you get theta equals 7 pi over 12 comma 11 pi over 12, like that.
Okay.
And the thing is that there's actually more answers here. So, and this is where it's like, I don't know whether to tell you how much we should dive in. So what the reason is because it's not only 7 pi over 6, but if you go all the way around again, it's 7 pi over 6 plus 2 pi. If you haven't seen this, or this looks unfamiliar, we should maybe not cover it, because it could like take away from like your understanding of this. So maybe let's just leave it like this, because I'm concerned maybe the understanding won't be there. If that's okay with you.
That's fine.
Okay. 8 is like the more traditional problem where you just, and you got the answers here. You just look it up on the unit circle and you're done. Okay, so 9 is this one is the one we should have started with, because it kind of, it'll help to kind of explain what I'm referring to. So again, you want to make, excuse me, you want to make this u. So tangent of u equals -1. And again, on your unit circle, you know, there's like certain nice places, like at 45 or pi over 4, tangent is 1, but also down here. And this is because the slope of this line is 1. When you go the other way, the slope is -1, and the those occur at 3 pi over 4 and 7 pi over 4. So u equals 3 pi over 4 or 7 pi over 4. But again, kind of like the last problem, you have to go back, and u is really theta over 2. And so if it's more comfortable, you could separate them and make it like this. It's really 2 equations. So you multiply by 2 on both sides, and you get theta equals 3 pi over 2. Theta equals 7 pi over 2. And remember how there's that whole like, well, are these in the interval? And the answer is this one is yes, but this one is not. And so this is where you do need to look for this. If you, it's like an exception. It's like, I don't know if you remember when you're solving like square root problems, and you get what were called extraneous solutions. That's what's going on here.
Oh.
So whenever you have a fraction inside here, that's when you usually have to exclude one of them. In the previous problem, what you have to actually do is write more solutions, because there's extra ones on here. So let me actually go back and address that. So the answer was, well, it's 7 pi over 6 plus 2 pi. Switch colors. So that what that really is, 7 pi over 6 plus 2 pi is let's see here, 19 pi over 6, because this is really 12 pi over 6. So when you divide this by 2, you end up getting, let me add this to the list here, 19 pi over 6 divided by 2. You end up getting 19 pi over 12. And that's okay. Like you, and maybe you're not, you're like, well, how do you know if that's okay or not? Well, the answer is, and that's why these are so much more complicated, is like, yeah, it's 0 and pi if you go left. But if you use the denominator, that's 12 pi over 12, because it's really just pi. This becomes 6 pi over 12, because that's pi over 2. And notice you're jumping by 6 to get 18 pi over 12. And then this one is 24 pi over 12. So as long as it's less than that, which is still 2 pi, you have to keep adding them. So you have to do the same thing here with this 11 pi over 6, 11 pi over 6 plus 2 pi, which ends up being 23 pi over 6, which ends up being 23 pi over 12. And that's like the full answer. And if you forget, like most students don't remember this the first time, just you gotta do a few problems to see that. Okay, let's maybe take a look at 10 next.
Mhm.
Okay, so again, set sine u equals √3 over 2. On your unit circle, you're looking for a y value because sine is the y value. That's the taller one, like that and like that.
Mhm.
So that's pi over 3 and then 2 pi over 3. So you're feeling really good. You're like, all right, I got my answers. No big deal. All right. And so theta over 2 equals pi over 3, comma 2 pi over 3. And then you got to solve. So you multiply everything by 2. By 2, by 2. So you end up getting 2 pi over 3 and 4 pi over 3. And then you check, are these still in that interval? And these are both good. But it tends to be, again, it tends to only be like with question 7 where you have a number in front that's bigger than 1 that you have to add solutions. These are easier because you end up subtracting them out. All right, should we look at 12 next?
Yes.
Okay, so I was just showing you some like problems earlier where it's like, well, this is the analogous problem. Like how would you solve this on the right? And you might think for a while and they say, oh, well, I can factor an x out. Well, here you can factor a cosine out. So you get cosine theta, 2 cosine theta plus 1 equals 0. And then on the right, you know to set them each equal to 0, each of the factors. So here on the left, you do the same thing. You set each of the factors equal to 0. So cosine theta equals -1/2 and cosine theta equals 0. And from here, there's no like patterning of answers. It like cosine of theta is 0 at pi over 2, 3 pi over 2. Could be that there's only one answer. Could be that there's more than one answer. Cosine theta equals -1/2. It's the x value. So the x value there and there are -1/2.
Mhm.
So that's it's 2 pi over 3 and 4 pi over 3. And so these are all answers. These are all good. Notice like we didn't have like a 1/2 theta inside or 1/2 theta inside, so we don't have to modify the answers at all.
Okay.
All right, so starting at 13 through 18, do we want to do all these? Do you want are there some that maybe are more I mean, we probably can get them all done, but I just want to ask if that's what your goal is.
I feel like I'm getting used to them. We could go through all of them, but could we start at number 18?
Oh yeah, and there's another page too. I forgot to even see that. Yeah, so you want us to go backwards?
Yeah, we could go backwards.
Sure. Yeah. So 18 takes us back to that reference sheet, a trig cheat sheet that I mentioned. So cosine 2 theta is a formula, and if you don't know this, you can't do this problem. It's just impossible. So it's under double angles. I'll snip it in here. This again, like trig is so heavy on formulas, students really they don't like it very much. these are the three variations or the three flavors of it. So you got to choose one. It's like, well, which one do I choose? Well, it depends on what else is going on in the problem. So see how there's a cosine here on the right?
Yeah.
That's an indicator that you want to choose this one because you want to just get cosines in your problem. So here we take this and make this 2 cosine squared theta minus 1 plus 3 equals 5 cosine theta, 2 cosine squared theta. And then this is plus 2, but I'm going to bring this over. So minus 5 cosine theta plus 2 equals 0. Again, like your analogous problem here is 5x squared minus 5x plus 2 equals 0. And sometimes it's easier to just factor this one on the right rather than trying to make this work. This one, apparently, oh, I wrote the wrong number. It's 2. I was like, well, that ain't gonna work. So gotta get the right thing there too. So minus 1, minus 2. And so why does that matter? Well, we're basically saying x is cosine theta. So it's 2 cosine theta minus 1 times cosine theta minus 2. So cosine theta equals 1/2. Cosine theta equals 2. So last problem I mentioned, like sometimes there's no patterning of answers. Like this one has no solution on the right. You might think, well, how can I have no solution? Well, if you remember the graph of cosine, starts high, goes low, comes back up. Oops, let me put that last part. And then but it does this forever, and it's bounded at 1 and minus 1. So it never touches 2, never hits it. The one on the left, though, does have solutions. It has solutions at pi over 3 and 5 pi over 3. So the previous one had 4 solutions. This one had 2. Some have 3, some have none, some have 8. All right. Moving backwards, I can go to 17 or move forward to 19. Which would you prefer?
Let's just get 19 and 20 over with.
Okay. Okay, so 19, I actually it follows really well from the previous problem. It's just a factoring thing here. Two numbers that multiply to minus 4. Well, I'm sorry, this is a guess and check approach, but it ends up being minus 4 plus 1. And so you said each of them equal to 0. You said 2 cosine theta plus 1 equal to 0, cosine theta minus 4 equal to 0, cosine theta equals 4. That again has no solution. The one on the left, though, cosine theta equals minus 1/2. And that gives you, again, on the unit circle, we've probably already done this one. So minus, yeah, right there. Okay, that's 2 pi over 3 and 4 pi over 3 for that. Twenty is very different because you get in such a pattern of like, oh, I factor or I set terms equal to 0. Actually, I take that back. This one looks like it's because it's a squared. You sometimes look for those Pythagorean identities that I was mentioning. So tangent squared, if you go back, I'm going to snip it in. Your tangent squared here is, well, plus 1 equals secant squared. So if you subtract 1 from both sides, tangent squared theta equals secant squared theta minus 1. So on the left, it's secant squared theta minus 1 equals 3/2 secant theta. And like, you're like, well, what do I do from here? We're going to clear the fraction first. So that's 2 secant squared theta minus 2. This on the right becomes 3 secant theta, and then you subtract it over, so you get it there on the left.
Mhm.
And like the previous problem, you factor 2 secant theta, so like -2 + 1. You can check these later if you want to see how they work, but because it's a previous class, they're like, oh yeah, you should know how to do this, which,
Yeah.
I don't know if that's fair or not, but that's what they say. Okay, now you don't know secant, and neither do I. Like, I'm not like, oh yeah, here's my secant, unit circle. You do know 1 over cosine is secant, and if you flip the left, you flip the right. So cosine theta equals -2, cosine theta equals 1/2. Again, that one on the left has no solution. The one on the right is, pi over 3, comma, 5 pi over 3. So you gotta know your unit circle, or you gotta have one printed out right next to you.
I think she lets us use unit circles on our exams and stuff.
Okay, that makes it a lot more
Yeah.
pleasant. Students dread it. They're like, how do I do this? It's like, I don't know. Same way we all do, I guess. You learn it, or but I mean, the unit circle is it's a really key thing, but you're going to go through the rest of your life, unless you go and study math or even engineering. I mean, you're not going to, nobody's going to ever be like, what's the sign of, pi over 6? But you got to know it for this class. So we learn it here. All right. So again, whenever you see something squared, and see how you got a cosine squared and then a sine, they're mixed, which means that you got to do something. You're like, well, what do I do? Well, whenever you see squares, also you think identities. So that first identity is this one here. It's the Pythagorean identity. And sometimes there's a question of like, well, which one do I substitute in for? Well, in this case, cosine squared. So if you subtract sine squared theta from both sides, cosine squared theta equals 1 minus sine squared theta. So this becomes 1 minus sine squared theta plus sine theta equals 2. And in the past, I've been moving everything left. Whenever the leading term is negative, my preference is to move things right. Okay, which could be a little bit odd, but and then you actually flip the order. Like when I add sine squared theta, it's positive. I subtract sine theta, it's negative. And then I'm subtracting 1 plus 1 here equals 0. But, oh boy. This one, I got to move it back. No, I'm looking at this and I'm saying this doesn't factor. So what do we do? Let me graph this one real quick and see if it has any solutions before I do that. And that's kind of the cheat, is like if you have a graphing calculator or Desmos, this one actually, so yes, this equals 0. This one actually has no solutions by the quadratic formula. That might be a good one to ask, like, hey, do I need to know that or not? But you would find that this has no solutions.
Okay.
I know I started late, so if you want, I'm willing to do a couple more problems here, or we could stop here, but let me know if you'd like me to move backwards further and get a couple more done here.
I'm not very good with the tangent stuff, so can we just end on number 16?
Yes. So just like in, I think it was question 1, 2, 3, it was like 4 and 5. It's always a good idea to kind of go right to sine and cosine. This is cosine over sine. And then you want to cross multiply here. It's generally the approach here. So on the left, you get sine squared theta. On the right, you get cosine squared theta. And now you're like, well, what do I do? Like, well, just like in the last problem, you go to identities when you don't know what to do. So let's take a look here. And this is what I meant by, like, sometimes you're like, well, which one do I substitute in for? Well, your choice. So I'm going to choose, because we did in the last problem, cosine squared theta equals 1 minus sine squared theta. So on the right here, it's 1 minus sine squared theta. I'm going to add sine squared theta to both sides. So 2 sine squared theta equals 1. Divide by 2. Sine squared theta equals 1/2. Take a square root of both sides. Okay, and on the right, it's plus or minus square root of 1 over square root of 2, plus or minus 1 over root 2, multiply top and bottom by root 2, ends up being root 2 over 2, which is nice because now you can actually find it on the unit circle. Whereas if you didn't, you would really struggle. So root 2 over 2, that's at pi over 4. And then again at 3 pi over 4. And this one's 5 pi over 4 and 7 pi over 4. All right, so I now rushed through that. The rest can also all be solved with Desmos. Like if you want to check your answer, you would like either graph the first one, like sine theta, and then cosecant theta, and see where they intersect, or you can move them both left. Like you could say sine theta minus cosecant theta and see where it equals 0.
Okay.
So if you're really stuck, do that. All right. So I know we went through it really fast, but if you understood most of it, you're going to be in great shape. Thank you for your patience with me tonight.
Yeah, of course.
I'll send you the notes here shortly, and I'll see you next time.
Okay, thank you.
You're welcome. Bye now.